In this video, we're going to look at using the dot product between vectors to calculate the angle between them. So we've got here two vectors, A and B, and they are written in the Cartesian form, so 2i minus j minus 2k. So they are 3D vectors. So if you think about visualizing them, vector A is 2 units along the x-axis, minus 1 unit down on the y-axis, and minus 2 units out on the z-axis. So we've got a 3D vector in space. We've then got another vector, which is vector B, which is at 3i plus j minus 3k. So if you imagine, we've now got another vector line in space. And what we want to do is we want to work out what the angle is between these two vectors. So the way we can do this is by using a dot product and the magnitude of the vectors. So the equation that we need is cos of theta, so theta being the angle between them, equals the dot product between A and B divided through by the multiplication of the magnitude of both vectors multiplied together. So there's essentially 3 steps that we need to do here. We need to work out what the dot product is between the two vectors, and we need to work out the magnitude of the two as well. So vector dot product, the method that we use, so we take the I components and we multiply them together. So we do 2 times 3 plus the j components multiplied together, remembering to bring the sign with it, so that's minus 1 times 1, and then plus the k components multiplied together, again bringing the sign, so minus 2 times minus 5. Now if we evaluate that, we got 6 minus 1 plus 10 will give us 15. So the dot product between A and B is a value of 15. So remember, when you're doing the dot product, you always get a scalar out from it, so it's always a number out. That's why it's also known as the scalar product. But if you're doing the cross product, which is also the vector product, you get a vector out from it. So that's a slightly different operation. Next, we need to know the magnitudes. So the magnitude of vector A. So the magnitude is the length of our vector. So thinking about it, if it was just a 2D vector, the length would be the hypotenuse of a triangle. So all we've got is we've got a 3D vector. So it's the same concept. What we do is we take the square root of the square of each one of the I, j and k terms. So 2 squared. Now just for consistency, I'll write the minus 1 in, but obviously as we're squaring it, it won't make any difference. So if we evaluate that through, so we've got 2 squared plus 1 squared plus 2 squared, square root the whole lot, and we get the value of 3. If we do the same for B, be the square root of the I component squared, so 3 squared, the j component squared, and the k component squared, and we're taking the square root of all of that, and that comes out to be 5.91. So we've now got the 3 bits of information that we need, so we just substitute those in. So we've got cos of theta is A dot B, which is 15, divided through by 3 times 5.91. And if we want to work out theta, we're doing the inverse cosine of this. 15 over 3 times 5.91, which works out to be 32 1.2 degrees. So that's the angle between those two 3D vectors in space.